Alright, today's section, 10.5b, we're going to focus on graphing polar equations. So we're going to focus on the different special kinds. So here's some polar graph paper that I'm going to use. I think I'm actually going to go ahead and get rid of the lines. Let's go ahead and do this, and I want us to graph r equals to 3 cosine theta. So in order for us to get these done, we are going to be graphing by hand, and we're going to make a table. Now in class I have some polar grid papers for you guys that have the little table chart right next to it and the angle measures to kind of help you out. So if you want to use those, that's good, but realize that you should be able to set these up by hand anyways. So we're going to be doing all of the trig function values that we know of off our unit circle until we know exactly what this looks like. So I'm going to go and list out 0, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, and we're going to continue this on down, 3 pi over 4, 5 pi over 6, and pi. We'll stop with that for now. I don't know if any of you guys know what the shape of this graph is supposed to produce, but let's kind of just see what we have right now. Always start out with listing your angles theta first. Even though when you plot the points, you're actually going to plot the point r theta, so try not to get that mixed up. We need to plug in 0 here. So this really is going to be 3 times cosine of 0. Do you know what cosine of 0 is? It's 1, so we get 3. And so we're going to go over here to our graph and plot our points. And I have quite a few circles on here, so I'm going to go 1, 2, 3, 4, 5. I'm going to make every 5 circles unit of 1. Since I've got 3, I think that'll fit well. Here's 3. So when theta is 0, r is 3. So I'm going to label that point. Here's our first point. Oops. Here's our first point. Then we're going to move on to pi over 6. So I need 3 cosine pi over 6. And well, cosine pi over 6 is radical 3 over 2. You guys need to know that radical 3 over 2 is approximately 0.866. So for our purposes, you guys can use 0.9. That's going to typically be good enough for our graphs. So we're going to think of this as 3 times 0.9, or approximately 2.7. So at pi over 6, I'm going to have 2.7, and each one of these marks was 0.2, so I'm going to be somewhere in between the lines. Plug in the next one, 3 cosine pi over 4, and pi over 4, the cosine value there is radical 2 over 2. You guys are going to need to know that is approximately 0.707. And how do you know these? You got to memorize them. So we get 2.1. And one thing that you should also notice here is the numbers are getting smaller. Why are they getting smaller? Because the cosine value, which is your x value, is getting smaller because it's getting closer and closer to the pole. So let's see, 2.1 for pi over 4. So here's 2.1 will be right in the middle. Notice our points are kind of curving, kind of going that way. Remember, it's kind of like connect the dots. So that's kind of what we have so far. 3 cosine pi over 3. And what's cosine pi over 3 equal to? 1/2. So this is actually equal to exactly 0.5, so I get 1.5. So at pi over 3, I have 1.5. Oops, wrong line. Pi over 3, I have 1.5 right here. So again, you guys can sort of follow along. You can see how it's curving. Now we're going to use cosine pi over 2, and that's 0. So again, take a look at the numbers. What do we have here? 3 times 1, 3 times 0.9, 3 times 0.7, 3 times 0.5, and now this one is actually 3 times 0. And we have our values off that unit circle, which are really what you guys should have used when you first learned how to graph trig functions. You would see the pattern. So here, when r is 0, we're at the pole. So notice, what am I getting? What's being created here? Kind of looks like a circular piece. Well, let's continue on with this. So I'm going to write 3 cosine 2 pi over 3. Now I'm just going to fill out the whole table here. 3 cosine 3 pi over 4, 3 cosine 5 pi over 6, and 3 cosine of pi. Now 3 cosine 2 pi over 3, that's equal to negative 0.5. So I have negative 1.5. How do we deal with that? This is actually giving us the point negative 1.5 with an angle theta of 2 pi over 3. So from yesterday, do you guys remember what's happening here? Well, our angle is 2 pi over 3, which is in quadrant 2, which is along here. But because the r value is negative, our point has to get kicked back or thrown over to the other side. So now we're in quadrant 4, not in quadrant 2 anymore. So follow along with this line here that I've drawn for where 2 pi over 3 is. And now let's locate 1.5 and draw your point. So I'm going to erase these other green lines because I don't actually need those. And hopefully you can see that the graph is kind of continuing this way. These two, top and bottom, are matching up. Let's see if that holds true here. What is cosine 3 pi over 4? That'll be negative radical 2 over 2, so negative 0.7. So this is now approximately equal to negative 2.1. So let's take a look again. We're at 3 pi over 4, which is along this diagonal. And I need to have negative 2.1. So again, I am in quadrant 4. Notice how the point just follows along. And then my next one, cosine 5 pi over 6, that's our negative 0.9. So I have negative 2.7. And hopefully you can tell the last one is 3 times negative 1, or negative 3. So I have filled out my entire table. I'm going to get this next one, so that's going to be 2.7. Oops. Hard for me to see the circles. And then 3. And 3, I already have a point there. Now if we were to continue this, we could see that everything is just going to repeat. So if I were to plug in here what comes after pi, I would have 7 pi over 6. So I would have 3 cosine 7 pi over 6. And cosine 7 pi over 6 would be negative 0.9. So I would have a negative 2.7. So notice 7 pi over 6 would be down here in quadrant 3, but we want negative of that. With an r value that's negative, so it's going to get thrown back into quadrant 1, and notice there's already a point there. Okay, so it's just going to repeat, and we don't need our points to repeat, so we're just going to stop with the pi. Because it takes one cycle to complete this whole graph, we call that the theta interval of this graph, and it's pi. What that means is how long does it take to complete one cycle. Now, one thing that I'd like to point out here for you guys is that this is the equation of a circle, if you hadn't already noticed from our picture, and that it is symmetric across the polar axis. Remember, the x-axis is also called the polar axis, so it's symmetric top and bottom. Whenever you have a polar equation written in first order of cosines. Meaning cosine to the first power. You can have something multiplied by it, or it could be a multiple angle, but still just cosine theta, and it being the first power, not a square, not a cubed. It is going to be symmetric across the polar axis, symmetric up and down. Okay, so that can kind of be a guideline to let you know what to expect in terms of your graph. And so you can predict what will happen. So let's try. Oops, didn't quite work so well. So let's try another one. Let's graph r equals to 2 times 1 minus sine theta. So again, I'm going to make a little chart. I'm going to have theta here, and r equals 2 times 1 minus sine theta in here. Suppose I don't really need it up here. And I'm going to start with 0 again. And let's write 0. Pi over 6, pi over 4, pi over 3, pi over 2. Let me just stop there for now. Let's see what we have. When we plug in 0, we get 2 times 1 minus sine of 0, 2 times 1 minus sine pi over 6, 2 times 1 minus sine pi over 4, 2 times 1 minus sine pi over 3, and so on. So I'm just going to write these all out. And then let's think about what these trig values are. Sine of 0 equals to what? Remember, sine is your y value, so that's a 0. What's sine pi over 6? That's our 0.5. What is sine pi over 4? That was radical 2 over 2, so that's 0.7. And what's sine pi over 3? 0.9. And sine pi over 2 is 1. Again, notice the pattern in your numbers. 0, 0.5, 0.7, 0.9, then 1. Work out really nicely like that. When you have sine theta or cosine theta, you'll find that pattern. So we can easily write out what these approximate values are. So r will be 2 here. The next one will be 2 times 0.5, so it equals to 1. And the next one will be 2 times 0.3, so it'll be about a 0.6. And then we'll have 2 times 0.1, so that's about 0.2. And then 2 times 0, so I get a 0. So let's plot these points now. Now let's see what I can do here. I'm going to make, I don't know if I can fit this on here. Let's see what I had up above. Okay, I have to make every 4, 1, 2, 3, 4, equal to 1. Now, how did I know to make that 4 and not 2? Or with the scale being twice as large? Now I'm going to draw these on the other side as well before I continue. And the reason for that is, remember, these are concentric circles, so I don't really need to denote the positive or the negative. The positive or the negative is the distance away. Now let's take a look at this. Why did I choose my largest circle here that I need to fit a 2? Okay, this is what we call the maximum r value that we're looking at. What is the maximum r value going to be? Now take a look at where your sine theta is. What do you know about sine theta, or cosine theta for that matter? The maximum value of sine theta is going to be 1. The minimum value of sine theta will be negative 1. So if sine theta happens to be a negative 1, what happens when you plug it in there? You're going to get 2 times 1 minus a negative 1. So the maximum r value is going to be a 4. So I'm going to need to be at least 4 spaces away from the pole, hence I would need a circle with radius 4. Now all the values that I came up with so far are only 2, so I've got a little bit further to go from my pole. Now let me plot these points. So 0, 2. So when theta is 0, my radius is 2. When theta is pi over 6, my radius is 1. When theta is pi over 4, my radius is 0.6, so it's kind of close in here. And when my angle is pi over 3, my radius is 0.2, so I'm really close to the pole. Oops. And then when I'm at pi over 2, I'm at the pole. So take a look now what's happening to our points. It's getting really close to the pole. Now let's see what's going to happen when we plug in the angle after pi over 2, which is going to be 2 pi over 3. So I'm going to have 2 times 1 minus sine 2 pi over 3. Well, what is sine 2 pi over 3? 0.9. So you may notice that the numbers are simply going to get larger again. So 2 pi over 3 is the same as what I have here with pi over 3. 3 pi over 4 will be the same as pi over 4. 5 pi over 6 is going to be the same as pi over 6. And pi will be the same as 0. Now why is this true? Because the sine function is an odd function. It reflects across the y-axis. So therefore, if you're thinking about your unit circle, all the sine values on the left-hand side and the right-hand side of your unit circle, which are your y values, match up. So it's symmetric. So all of these points are going to be symmetric, and I'm going to have identical ones on the opposite side. So I've got a 0.2 here. I'm sorry, 2, and then a 1, and then a 0.6, and then a 0.2, which is way small. So I get this little shape here, which kind of almost looks like a little bird flying. Okay. Now, do you think that's our entire graph? I hope not, because it can't possibly just have those little pieces. We need to continue on past pi. So kind of have a little break here. I need to continue on and write out angles in the third quadrant. So that would mean for us 7 pi over 6, 5 pi over 4, 4 pi over 3, and 3 pi over 2. So we'll have 2 times 1 minus sine of the angle, and so on. So as I'm writing these out, see if you can figure out what those trig function values are supposed to be, and what's our pattern now. Okay, sine of 7 pi over 6. 7 pi over 6 is in quadrant 3, and that's a negative value, and this is going to actually be negative what? 0.5. But because there's minus and negative, this is going to turn into a plus. Sine 5 pi over 4 is a negative 0.7. Sine 4 pi over 3 is a negative 0.9. And sine 3 pi over 2 is a negative 1. So notice all the sign changes here that we have. So when we write these out, we get that the sine value, the R value is going to be 2 times 1.5, or 3. We're going to get 2 times 1.7, which is 3.4. 2 times 1.9, which is 3.8. And then 2 times 2, which is 4. So I need to get these last few points on here. So at 7 pi over 6, our radius is 3. So you need to follow along the third circle. And at 5 pi over 4, it's 3.4. At 4 pi over 3, it's 3.8. Ooh. And at 3 pi over 2, it is exactly 4. So 4 is right here. So notice the type of shape that we have here. I'm going to try my best to draw it accurately enough. And what about the remaining quadrant? What do you think? Well, this is going to be symmetric, so I hope you guys can use symmetry here. Okay. It's actually going to match up and repeat itself going back up this way. This will be 5 pi over 3. This will be 7 pi over 4. And then 11 pi over 6. We'll have all of those same points repeated over here. Well, let's go ahead and use symmetry and plot the remaining points that are on here. So at 5 pi over 3, we're going to be at 3.8. And then 3.4 and 3. So this shape that we have right here, anybody know what this is called? This is called a cardioid. It's kind of like a little heart shape. Okay, not quite exactly, but it's like a little heart shape. This is also sometimes called a limaçon, but more specifically, it's a cardioid. Limaçon is the family of all of these types of shapes. I encourage you to print out from online the list of special polar graphs, because there's a cardioid, there's a dimpled limaçon, there is a convex limaçon, and then there is a limaçon with an inner loop. So just several different types of those. Okay. Now, one other thing I wanted to point out about this graph is notice how it was symmetric left and right. So when you have an equation that involves first order of signs, it is going to be symmetric left and right. Again, that is useful because then you can cut out half of the points that you have that you're going to use to make this graph. And because this particular graph has a theta interval of 2 pi, it takes quite a bit of time in order to graph that whole thing. Okay, we are going to do one last graph for today. Let's put this over on the side. And we're going to do, let's see, example 3. We're going to do one with a multiple angle. We're going to graph r equals to 5 cosine 2 theta. And now because this is a multiple angle with the 2 theta in here, I expect all of you guys to make use of the pi over 12s. Okay, so I expect that. So we're going to go 0, pi over 12, pi over 6. Actually, every single one of those all the way through pi. So yes, there are significantly more points to include in here. Okay, I'll get back to these. Let's sort of fill in what we have. 5 cosine theta, 5 cosine 0. Now what happens when we plug in the pi over 12? Why did I ask you guys to plug in the over 12s? Because this is a multiple angle, cosine 2 theta. This becomes 5 cosine pi over 6, which is now something you can do on your unit circle. So cosine pi over 6 is our 0.9, so then we have 4.5. And then when we plug in the pi over 6, we actually get a pi over 3, and cosine pi over 3 is going to be 0.5. So I get 2.5. Then I'll have 5 cosine pi over 2, cosine pi over 2 is equal to 0. And then we move on down the line. So go ahead and fill these out with me or on your own. Okay, so I'm going to try and do little shortcuts here now. So we're going to go ahead and plug in some of these values here. So cosine 2 pi over 3 is a negative 0.5. Cosine 5 pi over 6 will be a negative 0.9. Cosine of pi is negative 1, negative 0.9, negative 0.5, and it kind of goes on from here. So some of you guys may notice the pattern, some of you may not. We may need to write them all out for now, I'm not sure. Kind of depends on how much you remember from your pre-calc stuff. So I'm going to write in 3 pi over 4, 5 pi over 6, 11 pi over 12, and pi. This will be all that I do. Okay, so cosine 3 pi over 2 is going to be 0. Cosine 5 pi over 3 is going to be 0.5. This is going to be 0.9. And then this is going to be 1. Notice we don't have the cosine function values with the over 4s anymore, because those got multiplied by 2, so we don't actually have any in there, unless we did had an over 8 that we were doing, pi over 8 somewhere in there, then we would have that show up. So here I've got negative 2.5, negative 4.5, negative 5, negative 4.5, negative 2.5. Again, notice the patterns, the numbers just repeat. So what is our largest R value here? Hopefully you would have known and predicted ahead of time that it was going to be a 5, because we have a 5 cosine 2 theta. So what I'm going to do now is I'm going to sketch these, and I'm just going to kind of draw in the X and the Y axis to help myself locate my points a little bit better. And I need to identify my scale on here. So in this case, I think because I have to go all the way to 5, I'm going to make every third circle worth 1. So 1, 2, 3, 4, 5. And then I'm going to repeat it out this way. Oops. 1, 2, 3, 3, 3, 3, and 3. Your eyes will kind of play tricks on you when you're looking at these if you're not careful. So alrighty. So when theta is 0, r is 5. So that's easy. When you're at pi over 2, it's 4.5. So it's halfway in. And then we have 2.5. And then 0. You should take note of the order in which you have plotted these points. So it's kind of going inwards. I do not suggest that you plot all the points and then try to connect the dots. You need to connect the dots as you go. So in this case, I'm going to draw these little arrows. I don't know if that's useful or not, but I'm going to draw, maybe I'll draw in the arrows. No, never mind. I will not draw in arrows. Just imagine where it's going. It's following this path. Then the next one, pi over 3, so negative 2.5. So note where pi over 3 is, and be careful, you got to go to negative 2.5. So pi over 3 is going to turn into 4 pi over 3, and we have to go 2.5, so we're in the opposite direction. Notice what's happening. It's actually curving out to that point. And then we're going to have 5 pi over 12, and that's negative 4.5. So we're over here. And then at pi over 2, you have negative 5. So instead of being up on the y-axis, you're down on the y-axis. Oops. It's really kind of tough to draw on this stuff. Can you tell what's going to happen here? It's going to loop back around. So we are at pi over 2 right now. So we're done through here. I'm going to continue on with 7 pi over 12, which is supposed to be in quadrant 2, but it's a negative r value, so we're negative 4.5. And then we'll have negative 2.5. And then we'll be back to 0. So notice how our graph is turning around and returning to the pole. So I'm going to draw these arrows in now to show the direction. So we're at the pole, and what happens now? At 5 pi over 6, we get 2.5. So 5 pi over 6, now it's a positive value. So notice our graph is turning around and coming back this way. Then at 11 pi over 12, it's 4.5. And then 5. Can you tell what kind of graph this is? This is going to be a rose curve with 4 petals. I do not want to see you draw your graphs like this, whether you have 4 points there or more. That is not what it looks like. That is not how it is sketched. Notice how we're sketching it. So far we've got this, and it's in that order. So I need to be able to see that. Please take the time to draw these properly. So now we ended here at pi, and I'm going to go ahead and use symmetry now. Because this is r equals to 5 cosine theta, I know that with the first order of cosines, this graph is going to be symmetric across the polar axis. Okay, so we are going to continue to plot points by using symmetry across the polar axis. Remember, the polar axis is your x-axis. And this is what is called a 4-leaved rose curve. And our theta interval is going to be 2 pi. Because notice we've drawn only from 0 to pi, and it is only half done. So I'm going to plot in the rest of the points. I'm going to use a different color. This is going to be 4.5, then the next one is going to be 2.5, and then back at 0. And then we're going to continue upwards. We're going to be here at 17 pi over 12, and it'll be 2.5. Oops, sorry, not the right one. We're going to be at 5 pi over 4. So it's going to give us the 2.5. Oh, hold on. I'm going to go ahead and go backwards now. It's hard for me to see. There we go. And then 2.5 over here. Or I'm sorry, 4.5 over here. 2.5 on this one. And then the pole. And we've got the last one over here. We're going to have this one being a 4.5, the next one over being a 2.5, and then our pole. These curves do not overlap, so you are not going to see, I'm sorry, not overlap, they do not cross. They don't look like that. Okay, they will not cross each other. So just be careful when you do these. Please take the time to do the points. You will not really be able to get by without doing the points right now for me until I know you guys are all really super comfortable with all of the graphs.